Welcome to this IBM Cloud Pak's demo showing how organizations can quickly develop, build, deploy, promote, operate, and manage cloud-native applications. To begin the demo, the business has asked the Mod Resorts team for an enhancement which they believe will boost website subscriptions and increase revenue. Working in IBM Cloud Pak for applications, the developer includes the necessary code changes. First, the developer adds a call to invoke the getVisibilityData method. Upon saving the code change, the code is committed to version control, accompanied with a description of the change. The commit action automatically triggers a build process, provided in the code-ready pipeline, to create and register the new container image. From the Red Hat Container Platform dashboard, and while the build is executing, the developer can view the logs in flight and see that a new container image has been registered. With the code changes working as expected in the developer's inner loop environment, they announce that the code changes are ready for deployment across a series of environments en route to production. And to provide a more meaningful container tag making tracking of container image deployments easier, the developer calls a webhook which applies a version number tag instead of the cryptic tag automatically generated by the build process. With the container image tagged appropriately and available in the trusted registry, the team can begin deploying the new container image across the pipeline. IBM Cloud DevOps for IBM Cloud Paks provides the DevOps capabilities enterprises need to successfully deliver new services and products quickly to the marketplace. Looking at the demo flow, we can see the change to the deployment files are imported from the version control system into the IBM Cloud DevOps repository. The release engineer then bundles these files as a collection or bill of materials, creating a snapshot capturing exactly which version of each YAML file was used in the deployment. Next, the release engineer kicks off the deployment process, pushing the YAML files to IBM Cloud Pak for Multicloud management. So let's begin the release orchestration process. It is important to share that the value stream view displays what stage business value is currently at across the pipeline, along with where potential bottlenecks in the pipeline may exist. Switching to the pipeline view allows the release engineer, along with other team members, to see what containers make up the application, the latest version of each container image currently available in the trusted registry, and what version of each container image is currently deployed in the environments making up the delivery pipeline. With a new version of the Mod Resorts UI container ready to go, the release engineer starts the flow by deploying to the dev environment. As part of the release process, the release engineer is able to select which containers and the versions of those containers which should be included in the automated deployment. Navigating to the release plan, the release engineer can click through to view the automated deployment process steps in action. Watching the automated deployment process, the release engineer sees the Apply YAML file steps, prereqs, IP, channel, subscription, app, being sent to IBM Cloud Pak for Multicloud management for processing. Next, a comment is added to the Mod Resorts UI event timeline in IBM Cloud Pak for Multicloud management, sharing that a deployment has occurred along with the deployment outcome, pass or fail. And as this deployment is in the dev environment, a set of API tests are run to check application functionality. Returning to the pipeline view, the release engineer confirms that the deployment was successful and that version 1.1.0 of the container image has been deployed to the dev environment. For our demo, auto-promote has been enabled for dev to QA. This means that if a deployment is successful and the tests pass, the container image will be automatically deployed to QA, where additional application functionality and performance checks will be performed. With the latest versions of the container images tested together, they can now be deployed to production as a complete application. Same as before, the release engineer selects the container images to be included, and the deployment plan is run, deploying multiple container images to the production environment hosted on IBM Cloud. Turning to the IBM Cloud Pak for Multicloud Management user interface, the end user can see a topology view of the deployment including the cluster, subscription, placement rule, and application implemented using the specifications provided in the deployment YAML files. And finally, browsing to the public URL, the team can verify that the new feature is now available to the end user. A quick check confirms that it is working as expected. As container images are created once for deployment anywhere, let's look at how teams can easily move a container image from one cloud provider to another, Starting off in IBM Cloud DevOps for IBM Cloud Paks, the release engineer navigates to the Mod Resorts UI Application Environment view. Opening the production environment allows the release engineer to quickly modify the environment variable placement rule. Setting this environment variable to the desired cloud provider informs IBM Cloud Pak for Multicloud Management where that container image should be deployed. And with the placement rule set to AWS, the engineer kicks off the automated deployment. In reviewing the deployment steps for AWS, the release engineer sees that the prereqs YAML file is applied to set the policies for the cloud environment and to ensure that the enterprise security standards and regulatory compliance requirements are met. And again, navigating to the Mod Resort site using a browser allows the teams to confirm that the application is available to the end user and working as expected. Continuing on in the demo, let's take a closer look at IBM Cloud Paks for Multicloud Management, and specifically the monitoring of services using the golden signals. To set the stage for what is to be shown in the demo, that end users are experiencing slow response times. We start with an alert notification sent to a Slack channel being monitored by the SREs. So let's begin by checking the golden signals. Working in the IBM Cloud Pak for Multicloud Management, the SRE reviews the incident details and sees that latency is rising with the Mod Resorts application. Expanding the incident, they note that it is a Kubernetes service being affected. Clicking the incident URL, the SRE is instantly taken to the Cloud Resources view and sees the golden signal monitors and the data for each. Hovering over the timeline entry, the SRE can see when the service started to display issues. Increasing the timeline view, the SRE sees more information shared by IBM Cloud DevOps regarding the new deployment, and that the deployment happened to occur at the same time where there was an increase in traffic and a decrease in the thread pool. To resolve the issue, the SRE will begin by searching for an existing automated runbook which could fix this current issue. The automated runbook is successfully executed and the golden signals are showing speedy improvement. Traffic is rising, saturation is decreasing, and latency has returned to normal levels. As a final step, the SRE closes the ticket. To recap, using the golden signals, the SRE was able to pinpoint root cause of the issue and execute an automated runbook to fix the problem, minimizing impact to the business. IBM Cloud Pak for Applications, IBM Cloud DevOps for IBM Cloud Paks, and IBM Cloud Pak for Multicloud Management delivers an integrated solution enabling organizations with modern capabilities spanning the delivery pipeline from end to end. Thanks for watching.